Hello everybody. Now, this video is a companion video to the probability video. The probability video is going to be interesting in that that is just an intro to probability. Now, the one that we are using today basically is going to, or in this particular video, is going to be where we would find the complement. Now, this TEACS number would be 7.6e. The complement of an event, okay, is going to be the set of all incomes in the sample space that are not included in the event. So, for example, in the event of rolling a 3 on a number cube, we know that that probability is going to be one thing. Now, the complement is rolling any number other than 3, which means that the complement is rolling a 1, 2, 4, 5, or 6. Now, some of you might be thinking that are watching these videos that are parents or otherwise, well, why do we need to verify that? And a lot of times what will happen is that knowing the complement will help you actually identify what the actual probability of the event is. Now, when I say the probability of the event, so if I had, say, I wanted to find what was the probability of flipping heads on a regular coin, okay? The complement is going to be the exact opposite. What is the probability of not getting heads, okay? And sometimes when I can identify that, it'll help me go backwards and actually identify the probability for what I'm actually trying to find, okay? So if it's not quite clear at this moment, it will be hopefully by the time at the end of this video. Now, the sum of the probabilities of an event is its complement, and its complement will equal 1. So, the probability of the event, okay? So the probability of rolling or flipping heads on a coin will be 1/2. The probability of not flipping heads or flipping tails will also be 1/2. So when I add 1/2 plus 1/2, that's going to give me 1. It must always equal 1. The probability of anything must always equal 1. All of the probabilities of the probability of what I'm trying to find plus the probability of what I'm not trying to find must always equal 1 or its equivalent. That means it must always equal 100%. That must always equal 1.0, or it must be always 1 out of 1, or its equivalent if it's in ratio form. You can apply probabilities to situations including random selection, such as drawing a card out of a shuffled deck or pulling a marble out of a closed bag. So let's look at the example that we have here. There are 2 red jacks in a standard deck of 52 cards. What is the probability of not getting a red jack if you select one card at random? So right off the bat, you may already know what the probability is simply by looking at this. But a lot of times when we're first learning probability, it helps to know what we are not trying to find in order to help us find what we are trying to find. Okay? So what I'm going to do is I'm going to go over to my work as always. Now, let's look back at the probability rules, okay? I'm going to always identify my sample space, find the number of favorable outcomes, and find the probability in a ratio form. That is the intro to probability. However, when I'm attempting to identify the complement, which is 7.6e in our TEACS, we're going to use the complement of an event. So I want to identify the probability and then use the complement formula, okay, to actually help us find the complement, okay? So in this case, I know that the probability of my event plus the probability of the complement is going to equal 1. So let's think about the problem that we had just a moment ago, okay? There are 2 red jacks in a deck of cards. So I want to write down the things that I know that always helps us. And then what is the probability of not getting a red jack? Okay? So flipping back to my work. I know that there are 2 red jacks in a 52 card deck. Okay? So I'm going to assign a probability of 2 out of 52 to the pulling a red jack. Okay? Pulling a red jack, sorry. Is that not jacks? Okay? pulling a red jack. Okay? Now my complement, not pulling a red jack, at this moment is my unknown value. Okay? So I'm going to mirror this. I want to assign 2 out of 52 as the probability of my event. Okay? Plus the probability of not pulling a red jack, and that needs to equal to be 1. Okay, so the probability of my event plus the opposite of that event must equal 1. Okay, so this is sort of like at this point solving for an equation. Okay, if I know also that this number here, 1, can be phrased as 52 out of 52. Any number over itself is always going to be 1. So some number, 2 over 52 plus some number will equal 52 over 52. So how do I solve for that? Okay, so I know that if I subtract, this is where it looks like an equation, 2 over 52 from both sides, this just becomes what? So when I subtract 2 over 52 from 52 over 52, that gives me what? 50 over 52, okay? Which we can then simplify to 25 over 26, okay? Now, if I were to convert that to a decimal, okay, which I'm going to do off camera here very quickly, okay? So if I wanted to do that, 25 divided by 26, that's going to give me 0.96, okay? 0.96 as my decimal version of the probability for not picking a red jack, okay? I'm going to equate that to about 96% as a percent. So overwhelmingly, it stands to reason, okay? If I want to find out the probability of the complement, okay, it's going to be the exact opposite of the event, in this case of not pulling a red jack. We see that there's an overwhelming possibility that I would not pick a red jack, phrased as a ratio or fraction, as a decimal, and as a percent. All right, as always, if there's any additional question about what you watched there, please back up the video. If that does not work, please come to one of my tutorials to ask me a question. Also, you may ask me any question that you'd like in class during class time. And as always, I will see you tomorrow.